The graph below shows the velocity time graph for a ball that is dropped and then bounces. Right. The first question says, define the term projectile. Now, we know that this chapter is from vertical projectile motion. So we want to talk about, what is this word projectile? What is it actually? So what I want you to do is quickly imagine that you and your friends, you are standing on an open field and you all have a tennis ball in your hand. Okay, now I'm going to ask you to throw the tennis ball vertically up into the air. So obviously you can think about how you'd do that. Maybe you would throw it underarm, over, or however, but you got to throw it vertically up. Okay, now once that ball leaves your hand, so it's no longer touching your hand and now you've let go of it and it's moving upwards into the air, what forces will act on that ball? Some of you are going to say applied force, and you are incorrect. Don't worry, I get that one a lot. Remember, my question was, what forces are acting once your hand has let go of the ball and the ball is moving by itself? There is no applied force. I know that your hand gave the ball its original velocity or its original momentum. That is correct. I understand. I agree with you there. But once the hand has let go of the ball, that force of your hand is no longer there. So there is no applied force acting on that ball. Okay? This is the same in Newton's laws when you've got an object sliding down a slope or moving up a slope. A lot of learners tell me, Kevin, there's an applied force. But there isn't necessarily an applied force in those questions unless the question said. But here in this chapter, there will never be. They won't give you an applied force. The person's hand was only the applied force while the ball was touching the hand. Okay? But this chapter, we're looking at what happens to the ball after it has left the person's hand. So then, Mike, I come back to my question. What forces are acting on the ball? Some of you are going to say, oh, I know, air resistance. Now, you are perfectly correct. However, in grade 12, we ignore air resistance. There are little air molecules, and they do get in the way, but we ignore them in grade 12. So then what else is there? Some of you are like, okay, well, there's nothing, Kevin. Well, if there was nothing, then, the object would just continue to keep moving upwards because of your hand that gave it an initial velocity. If there's nothing else, then the ball won't ever slow down and it'll just keep going up forever and ever and ever. However, we know that the ball slows down. Why? Well, that's because of gravity. We know that there is gravity. So if you had to draw a free body diagram of at any situation in this chapter, you're just going to have gravity. Okay? Unless they ask you to draw a free body diagram once the ball hits the ground or something like that. Then obviously the ground is also going to be a force. But I'm going a bit off tangent here. So I'm going along a tangent, aren't I? So a projectile is an object moving under the influence of gravity, or you could say of a gravitational force, you could also say gravity, I've seen that on some memos, of a gravitational force only. Okay? Or you could say here an object that is only moving under the influence of a gravitational force. Okay, so that's the only force acting on it. That is what a projectile actually is. Right. This question says, describe the motion of the ball between A and B. So here's A and B. Now, a big mistake I see with learners is that they look at this graph and they think, they look at the shape of the graph and they say, okay, so here the object's moving up. And if the line goes like this, then they say, the object's moving down. Not correct at all. What we need to do, and I'm going to draw this out for you really nicely now, is we need to take this original statement over here, and we need to be able to take that and be able to have a bit of a nice or a good picture, a decent picture in our head of what is going on in this question. So the first thing is that they tell us that the ball is dropped, okay? They tell us here the graph below shows the velocity time graph for the ball that is dropped. So let us imagine that there is some type of building and there's a balcony and your friend is standing on the balcony and you are standing on the ground. Okay, so let's quickly go get a little picture for you. All right, so let's say, for example, you're standing, or you or your friend, whoever you want, is standing over here, and this person is holding a ball. Okay, so here's a ball. It's a huge ball. And let's say you are standing here over there. Now, that person or your friend is going to drop that ball. That word drop is actually so important. It means that they're just going to open their hand and they're just going to release, meaning that the initial velocity will be 0. That is what the word dropped mean. They didn't say that the ball's going to be thrown. No, they just said the ball's going to be dropped. So what would the initial velocity be? 0. And that is exactly what we can see on the graph over there. Now, check this out. As that ball begins to drop, can we all agree that because of gravity, it will become faster and faster and faster? Okay, so maybe over here it's moving at 2 meters per second. Here it's moving at 4, and then it gets faster, 6, and then maybe it gets to the ground at 8 meters per second. So have a look at this carefully now. What is the object doing? It's moving downwards. So we know then that this must be downwards motion. So have a look here. These velocity values are positive numbers. So it means that the person that drew this graph, they decided that they would like down, because we know the object's moving down over here, which is over here. And that means that down is positive, and that means up is negative. That is important that you know that, because the person that did this graph, or the person who designed this question, they could have done it the other way around. They could have decided to choose up as positive, and you need to try to figure that out, okay? So I'll explain that once more. We know that for this part of the graph, based upon our understanding of what's happening, the object is moving down. We know that. But if you look at the velocity values, they are positive. So it means that down is taken as positive. Okay? So the object is just moving down, 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 and then reaches point B. So point B is down here, and then this would be point A. Okay? Let me actually just carry on now. Let's carry on, because we're going to need to know about this part anyways. Now, check this out. When this object hits the ground, it will immediately bounce back up. Now, if it was a perfect world where there was no such thing as a collision, or there was no such thing as, sorry, that was a silly question. There was no such, or a silly statement. There was no such thing as inelastic collisions. Everything was perfectly elastic. Then what would the velocity be when it bounces up? Well, then it would be exactly the same as this one over here. And in that type of world, the ball would actually just keep going right to the same height over here, and then it would go back down, and it would never ever stop. And it would be a fun world where we can just drop a ball and we can come back tomorrow and the ball's still bouncing. But that's not the way it works. We know that energy is lost down here. That's because the ball, you know, like if the ball slams into the ground, it gets a little bit squashed, okay? So that's a deformation. You're deforming the ball, and that takes energy. So when the ball bounces up this way, it's going to be less than this one over here, unless it was a perfect elastic collision. And they can give you an elastic collision in an exam. Your graph will just look like this, though. It'll just keep going there, dot, 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 to exactly the same on the other side, there, dot, 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 there, and it will never ever get smaller. It'll just keep going forever and ever and ever and ever and ever. So what we can see though is that, okay, sorry, I'm going ahead of myself. So what will happen is that it'll bounce up. But now here's the important thing. When it bounces in this direction, in what direction is it moving over there? Upwards. And what have we established? Upwards is negative. So immediately the graph does this. It goes from the 8, which was a positive, and immediately it goes all the way down to here. So it goes all the way from B to C, and now we can see that the velocity is negative. So B is the ground, but so is C. They are actually the exact same place. The B is just